Welcome back, students. We will continue looking more problems around the series of quadratic equations. Presently, we are learning or trying to solve the different sample and board problems around the zeros and coefficients of quadratic equation. If you directly landed to this video, kindly check video number 7 and video number 9 to understand the basics which is essential for solving these problems. So going to the next problem, problem 4, you will find 1, 2, 3 in the previous video. This is a continuation of the previous video. So kindly check the previous video for the first 3 problems. The question goes like the number of quadratic polynomials that has the zeros -5 and -3. Yes, these are the 4 options 1, 2, 3 and more than 3. This has been a quite repeated pattern. I could find some way or the other this question has been asking many times. So this is fairly simple, but let us crack it step by step. So the sum of the zeros, what the problem says is, let us understand the problem first. Alpha is -5, beta is -3. The question asks, how many polynomial equations can have -5 and -3 as its zeros? Is it one polynomial equation, two polynomial equation, three or more than three equations? So the approach goes this way. Now you know alpha, you know beta. Let us find the sum of the zeros first, which is -5 plus -3, which is equal to -8. The product of the zeros is -5 into -3 is equal to 15. You know how to fit the polynomial equation with the knowledge of the sum and the products. The polynomial equation form is x square minus sum of the zeros into x plus product of the zeros. So the quadratic equation, what is required or what is the answer is x square minus of -8, that is 8x plus 15. However, the question is asking how many, you have found out one polynomial. The question is asking how many polynomials can have this -5 and -3 as its zeros. So the answer is, if k is a real number, it can be anything. You can assume k, l, m, n, anything. If k is a real number, then k into the whole polynomial x square plus 8x plus 15 is the quadratic equations which can have -5 and -3 as its zeros, which k can have infinite number of values. So the answer is infinite, or it in terms of the options what your questions have, it is more than 3. So some questions, some years they have given the option as infinite polynomials. So that's why I have brought in both. To slightly better understand this problem, let me take you through example. Like I am assuming 3 values of k to demonstrate my case. K is equal to 3, 5 and 10. After multiplying this 3, we get this as a polynomial 3x square plus 24x plus 3 into 15 is equal to 45. So you get by multiplying 3 with this entire equation. Now let us find out what is the sum of this zeros, that is minus b by a minus 24 by 3, which is -8. This is what you find here, and the product is c by a, which is 45 by 3 is 15. That's what you see here. Now you can repeat the same for the next equation. When I multiply 5 with the entire equation, I get the polynomial as 5x square plus 40x plus 75. When you try to find the sum of this polynomial, it is -40 by 5, which is equal to -8, same as this equation, and the product is 75 by 5, which is 15. So you can repeat the same validation for this equation also. So what you understand is, you can have n number of polynomial equations which have the same sum and zeros, that is -8 and 15, indirectly, which is nothing, the having the same zeros, -5 and -3. So the option is, you have n number which is infinite, To be precise to the option what you have, it is more than 3. So now let us move to the next problem. Problem 5. This is slightly a twisted version, like the quadratic. They are asking you to find out the quadratic polynomial whose sum and zeros are 5 and 8. Okay. So I'm just again revising the equation. When you have the sum and product, when you have the sum and the product, the quadratic equation is x square minus sum of zeros plus product of zeros. X square minus bracket alpha plus beta x plus alpha beta. So in this case, the polynomial equation for us is x square minus 5x plus 8. We are going to substitute this 5 and 8 in this form to get the polynomial equation. But however, as I discussed in my previous problem, this is not the only polynomial equation which is going to have sum 5 and 8. Any real number which is multiplied with this whole equation, let the real number be k in this case, that also has the same sum and product. So your answer should be k into x square minus 5x plus 8, where k is any real number. These are the polynomials which have the same sum and product. So now let us move on to the sixth problem variety, where they have given the alpha. They are telling that alpha and beta are the zeros of this polynomial, and this interpretation is sum of the zeros is equal to product of the zeros. Here they have given straight away as a formula. Sometimes they could mention as a text saying that the sum of the zeros is equal to product of the zeros, in which case you have to put this format. So these are the 4 options. Let us see the way to solve it. First, you are going to find the sum of the zeros minus b by a, which is nothing but minus of minus 2 by p, which is 2 by p, and product is c by a, which is equal to 3p by p, which is equal to 3. Students, I have not written here, but whenever you write, you are supposed to first write the formula minus b by a, and here you are supposed to put c by a, then only substitute the values and show the values of alpha plus beta and alpha beta. This formula carries marks, and this step is very essential. Okay. Since they have told both are equal, alpha plus beta is equal to alpha beta, you are now going to equate 2 by p is equal to 3, and you get the value of p as 2 by 3, which is the option to B. So in the next video, we will continue to see such unique problem varieties which are basically repeated in some model papers or the previous board papers. Thank you. Bye till then.